All right, everybody, this is the last day of notes for the whole year. Today we're going to be doing 4.5, which is solving radical equations. The learning target for today is to solve equations that contain a square root. So we've solved lots of different kinds of equations this year, but today's the first official day that we're solving equations that contain a square root in them, not that have a squared exponent in them. A radical equation is defined as being an equation that contains a square root. And so it could technically be a cube root or a fourth root, but because this is Math 1, we just look at equations that contain square roots. And so don't worry about filling in examples for these ones because you're going to have plenty of examples of everything down below. And extraneous, the word is extraneous, kind of looks like extra, is defined as being an answer to a question that does not produce a statement of equality. An answer to a question that does not produce a statement of equality. If you wanted to give a different definition for extraneous solution, you could also call it a bad answer. And so you'll hear me use these words today while I'm talking about extraneous solutions. So take a look real quick at the 6 problems that are on this page that you're going to be solving for. So something that they all have in common is they all have equal signs. The stuff that we've been doing so far this unit has all been just simplifying, but today is the first day that the directions to the question say to solve. So we're going to be getting answers to questions that say x is equal to something and x is equal to something. It says to check for extraneous solutions, and so we'll make sure that we practice checking for fake or bad answers that pop up in the questions. And then it says once you're done, you're going to circle the number of real solutions that the radical equation has. So once we're finished with each one, we're going to say how many answers it has. So today in the notes, I'm going to use a red pen to show you the thing that's the new thing that you're doing to solve each equation. So let's look at example 1a to start. It says the square root of x plus 6 is equal to 8. Notice how the 6 is underneath the square root. So it's kind of like it's stuck over here on the left-hand side of the equation. The rule with math is that when you're trying to solve an equation, you can do anything to one side that you also do to the other. And you want to use opposites. So usually if you see addition, you do subtraction. If you see multiplication, you do division. So the opposite of taking the square root of something is squaring it. So to go through and to simplify this equation, what I'm going to do is I'm going to take the square root of both sides. Now, I try to be consistent and always put parentheses on both sides when I square both sides. So I went back and I fixed that right here. Technically, you could do this without drawing parentheses on both sides, but it's better to do it this way so that way you don't make a mistake if later on a parentheses would make the difference. So just do it. All right, when you square something, the squared and the square root cancel each other out. So this side over here now is just going to say x plus 6. Notice that the square root part over the top is gone. And then when I square this side, the 8 actually changes to say 64 because the 8 wasn't underneath the square root. So notice how on this side, the 6 doesn't turn into 36, it just stays 6. But on this side, the 8 turns into a 64. Now my equation is easier to solve because all I need to do is minus the 6 to both sides. And so I get x equals 58. And that's my answer to the question. 58 is the one number that if I plugged it back into this equation, I would get the right answer. And so sometimes students think it's helpful when they're learning this for the first time to actually do that work and plug it back in. So to check my answer, I can say when I do 58 plus 6 and I take the square root of it, I'm supposed to get 8. So this would say the square root of 64 equals 8, and then I would get 8 equals 8. We won't be doing a check today on every problem, but it is good for you to see how they work out to get the answer to each question so that you can understand that this number is the number that if you plugged it in here, it would make this equation be true. So on letter A, we started by squaring both sides because the 6 was stuck underneath the square root. Look at how letter B is different. On letter B, the 3 over here isn't underneath the square root. It's kind of all by itself. So when you solve radical equations, you have to get the part that has the square root all by itself. So on this one, I subtracted the 3 from both sides first. So over here, the 6 was stuck underneath, but over here, the 3 wasn't stuck underneath. So if there's any numbers in front of or behind the part that has the square root, you always want to move them over to the other side before you start solving. Now that this is all by itself, this is the part that I'm going to do in the other color. I'm going to square this side, and I'm going to square this side. If the square root of some number gives me 7, that means that the number that I would have had to have started with underneath the square root would be 49. And so this again is the one answer that works for this problem. Let's check this one too. So the square root of 49, and then if you add 3, you should get 10. The square root of 49 is 7, and then 7 plus 3 gives you 10, so it works. So you can always plug them in and you can check your answer to make sure that the answer to each question is working. Question C poses a little bit of a difficulty. You don't know that it's going to be different yet, but look at how it's set up. So the square root of 2z and then a plus 6. So I'm going to start by moving the 6 over to the other side. And so I have that the square root of something times 2 is coming out of a square root as a negative number. And so this is where you want to stop. The answer to this question is no solution. It's technically no real solution, but for our class, you can just say that it's no solution, and those two things will mean the same. The reason why this doesn't work is because nothing can ever come out of a square root and equal a negative number. Square roots never come out negative. The only way that would work is if there was another number in front of it that was negative. So since square roots never come out negative, it means that the answer to this question is a bad answer. You're taking the square root of something, you're adding 6 to it, and it's getting smaller. That just doesn't work. So we say that this has no solution. Next year in math, you'll say that it has no real solution. But the point is that there's no number that can work for z that would make this be true, no numbers that you know about anyways. And so when you're doing your work for letter D, you'll minus the 6 from both sides. So the square root of 4b is equal to negative 5. And so that's again when you stop and you recognize that this one also won't have a solution. So this will be no solution. Or if you want to be fancy, you can write no real solution. That's fine too. But there's not an answer to this question. It doesn't have an answer. So E and F both have answers. On letter E, notice how there's 2 things underneath the square root. And so when you have 2 parts that are underneath the square root, you need to start by moving one of them over to the other side. Anytime I have something and I want to move it over to the other side, I just do the opposite of whatever operation it has. So this one says the square root of x minus 1 is equal to the square root of x minus 1. And then I have 1 square root on the left and I have 1 square root on the right, so that means that it's time to square both sides. Squaring something is the opposite of taking the square root of it, so the square roots would both go away. And then I have x minus 1 is equal to x minus 1. You could take this a step further and actually subtract the x's from both sides. So you'd get negative 1 equals negative 1. You ask yourself, when is this true? Negative 1 equals negative 1 all the time. And so the answer to this question would be infinitely many solutions. So every number would be an answer to this question. Any number that you were allowed to put in for x would work because you would be getting the same value out for this one as you would for this one. So no matter what number you put in for x here, you would get the same number, you would put the same number in for x here, and then when you take the square root of something and then minus it from the square, or minus the square root of itself, you would get 0 out all the time. Anytime 2 things are equal, they always give you 0 as an answer. So there's tons of answers that would work for this one. We don't have to do a check for this problem, just like we didn't do a check for these last 2, because when they have no solution, there's nothing to check. And when they have infinitely many solutions, you would be here all day long plugging in numbers. So we just say that this one has infinitely many solutions. The last one has kind of a special thing that happens. So you want to make sure that you pay extra special attention to this one because it's a little bit tricky. I have w equals the square root of 2w plus 3. So the part that's with the square root is all ready to go. I can't minus the 3 from both sides to start because the 3 is stuck underneath the square root. So I'm going to start by squaring both sides. W squared is equal to 2w plus 3. So this problem is different because when you square both sides, you create a w squared, and then you have to go back in your heads to the last chapter that we did. So Unit 3 was the last section that was covered. So solving quadratics, this has a squared, so it has an a term, it has a b term, and it has a c term. So we want to follow the process for that. The first step says you're going to move everything over so that it equals 0. So it's going to turn into w squared minus 2w minus 3 is equal to 0. And then you want to go through and ask yourself all the steps and the answers to the question. So you have it equals 0. It has a b term, so you know you can't do the square root method. You can't hockey stick anything out, but you could t-chart it, -3 and +1, because that would give you -2 for the middle, and then that would give you -3 for right here. And then when you're solving, you set each one equal to 0. So you get w equals 3. And then on this side, when you set it equal to 0, you get w equals -1. So here's the deal. This question actually doesn't have 2 answers like you think it might right now. It actually only has 1 answer. And that's because one of these answers, when you plug it in, is no good. It creates that fake answer that you don't want to have. I'm going to try to squeeze the work in for this down here. It's going to be a little bit snug, but I'll try my best. So I'm going to start by plugging in the number 3 so you can see how the number 3 works. So 3 equals the square root of 2 times 3 plus 3. So that would be 6 plus 3. So 3 would equal the square root of 9. So 3 would equal 3. So as you can see, when you plug in the number 3, excuse me, when you plug in the number 3 for this equation right here, it's good. It gives you a good answer, not a bad answer. So this answer would be one of the answers to the question. But something different happens when you plug in the -1. So -1 equals the square root of -2 plus 3. So -1 equals the square root of 1. So you get -1 equals +1. And that's not true. So this answer, it's usually going to be, oh, that's not how you spell usually. If it's going to happen, it's usually going to be the negative answer you throw away. But in this problem, w equals -1 is an extraneous solution, so it gets chopped. It's not going to be part of the answer to the question at all. You're going to say that there's only one good answer to this question, because when you plug in a -1, it gives you a fake answer. It gives you an answer that's not good, so it gives you an answer that shouldn't be a part of the question. So -1 is extraneous in this problem. So it doesn't count as being part of the answer to the question overall. Okay? Go on ahead and flip your notes over to the last page. Here we go. Question number 2 says, a student solved this equation and found the solutions for -1, and they want us to describe and correct their error. I've been saying this a lot this year. When it says describe and correct means that you're going to use words. That's the describe part. And then correct means you're also going to fix it. But more than that, you guys, if it says to describe and correct the error, it means that this is wrong. So you're not allowed to say, I think it's right, because they're telling you that by the answer to the question is that it's wrong. So let's see if we can follow through the work that they did and find the answer to the question here. It looks like they squared both sides, which is good, because the 4 is stuck underneath the square root. And then it looks like after they squared both sides, they got rid of the square root part, so that's good. they moved the 3 and the 4, the 3R and the 4 over here, and they did that correctly. Let's see if their t-chart was right. -4 and +1. Yep, because that would give you -3. And so then they set each one equal to 0, so they got R equals +4, and they got R equals -1. And it's okay that they didn't show their work, because on these kinds of questions, they usually don't have you show your work on the questions. So this was given. On this one, they squared both sides. Here they simplified. And then on this one, they set it equal to 0. Here's where they t-charted. And then here they used the 0 product property, and they set each part equal to 0 to solve. So right now, you might be feeling confused because it sure does look like they did everything right that they were supposed to, but this is a radical equation, and they got 2 answers where one was positive and one was negative. So it's going to look like, let's see, it's going to look like I'm guessing that what happened was they forgot to go back and check and plug their answers in, because you need to double check and see if both of them will work. I'm guessing it's probably going to be the -1 that's no good. So let's check the 4 first. So 3 times 4 plus 4 is equal to 4. So let's see. 3 times 4 is 12. The square root is 16. And then I get 4 equals 4. So it works when you put in a 4. So this answer is a good answer. But remember how I said on the last one, it's usually going to be the negative number. So if something doesn't work, it's usually going to be the one that's negative. And that's actually what's going to happen here. So I'm going to get the square root of +1 equals -1. But 1 doesn't equal -1. So it looks like that what happened was when they got their answer to the question, they forgot to check for extraneous solutions. And so to fix it, we would need to fix their answer. So this one would be crossed out, and you would just keep this one as your answer. Look at all the work that I've written down so far while I was doing this example. Notice that I haven't actually answered the question yet, and I kind of ran out of space. So let's see. I'm going to try to squeeze it in right here. So they forgot to check for extraneous solutions. And then I'm going to say R equals 4 is the only answer, is the only true answer. You could also say that they forgot to cross off -1 as a bad answer. You could say -1 is an extraneous solution, so the only answer is +4. Any way that you want to think about wording the answer to that question would be fine. All right, let's see. Question number 3. This is the kind of question that gets students mad because it's at the end of the notes. It's also our last example of the school year. It says if you know a sphere's surface area, the formula to find the radius is given as R equals the square root of S over 4 pi. So S represents the sphere's surface area. It says suppose a sphere had a radius of 8 centimeters. So I'm going to be using this formula. R equals the square root of S divided by 4 pi. And then it says that the radius is 8. So I'm going to go ahead and put an 8 in right here. And then the directions to the question says, what is the surface area? And they want me to round to the nearest hundredth. I didn't mention this at the beginning of doing this problem, but just remember that a sphere is a 3-dimensional shape. It's like a round circle. Well, circles are round. It's a 3-dimensional circle. So it's like a basketball or a baseball. Those are all examples of spheres. Just to give you some background with that so you know what we're talking about. But back to solving the problem. This is an S, not a number 5. Sorry, sometimes my S's look like 5s. But I'm going to go through and do the same steps that I just practiced. So all this stuff is underneath the square root, which means that it's time for me to go ahead and square both sides. So that's going to turn into 64 is equal to, and then this side is just going to be S over 4 pi. And so there's not going to be any square root left over because squaring both sides caused the square root to cancel out. And then the very last thing that I need to do is I'm trying to get the s all by itself because I'm solving for surface area. I'm going to times both sides by 4 pi, because anytime you have a fraction and you want to get something out of the denominator, you can multiply both sides by what's in the denominator. And so that's going to give me the answer to the question. So I'm going to get 256 pi is equal to s. So I can write my answer as 256 pi centimeters squared, because I'm finding surface area. So with surface area, you'll always write a squared right here. So this is the exact answer to the question, but the directions to the question also wanted me to round it to the nearest hundredth. And so when you're typing this into your calculator to write it to the nearest hundredth, sorry guys, I gotta find my calculator. When you're typing it into your calculator to round it to the nearest hundredth, you want to make sure that you use the right button on your calculator. Pi is not 3.14. I mean, it is. But we're not going to use that for us because we want to round this as appropriately and as accurately as we can. So make sure that when you do this and you round it, you use the pi button. This should actually have a wiggly equal sign because I'm about to round it. So in my calculator, I'm going to type in 256, and then when I do pi, the pi button's right over here and it's above this little caret. So I'm going to press the second button and then press this caret exponent button, and that gives me 256 pi. So that's going to give me a more exact rounded answer than if I had used 3.14 for pi. The directions to the question say that they want me to round it to the nearest hundredth. Hundredth means 2 decimal places. And so if I round my answer for this one to the nearest hundredth, it's going to be 804.25 because the 7 would make the 4 round up to a 5. So it'll be 804.25 centimeters squared. And so that's my rounded value. The directions to this question had us, they just had us write the rounded answer, but we, in geometry, and so in your math teacher's class for next year, you're probably going to write your answers more like this. So I thought it was helpful for this being your last example before you move on to sophomore math next year for you to see the answer written out both ways. So congrats, guys, you're done.